So in the last video, we were talking about the IX addressing mode. In particular, we had this example where we wanted to load the ith element of an array Z. So we're going to pick up here. I've typed up the assembly code that we used in the last example. And if you want to just pause the video and read through this and make sure that you understand what's going on, I'd encourage you to do that. I'll briefly cover it now. First, I want to note that I have not explained how this is happening, right? I haven't said how we define variables yet, but just for now, let's just trust that Z is a variable array in memory with address hex 0120. I, similarly, is a variable that we want to use to get to Zi, so we want to read the ith element of Z. Okay, so now we're going to talk about this load statement. We're loading the address of Z. In other words, Z is 0120. Z is also an array which has 6 bytes of space that contain, in this example, the word hello in ASCII with a null terminator. This is a very important distinction. Z is not a pointer. You can add stuff to Z, and the assembler knows what that is, but you can't increment Z, you can't change Z. You'd be changing the contents of Z if you did it. It's not a variable that holds an address. It is a variable that is at an address. And so when we use this here, we're saying use the address of Z, because Z is the variable's name, and that variable's name is identically the spot where it's held in memory. It's worth driving this home a little bit. If you were to write a statement like load I, right, this is saying go load into the accumulator the value of I. There are a lot of different ways that you could write this statement. You could load A with a hex value of 0100. Now, you could also say something like load into the HX register the value 0100 and then do an index load. You could do lots of different things. It would say go out to that spot in memory and load that value. It's important to know, and you should be quite comfortable with the fact that these two statements are actually identical. So the first thing that the assembler is going to do when it sees an I here is it's going to say, I don't know what I is. It's going to look around and say, is I like is that a label that I know? Is that a spot in memory that I know? And it's going to go back up to how we define a variable, which we'll get to in a later video. And it's going to say, oh, I is a location in memory. Specifically, it's 0100. So it's going to change. The assembler will take this statement, change it into that statement, and then compile this statement here. There's no machine code for I. We can't have I there. We have to have an address. The difference, of course, is if we put in here something like this, where we put an immediate value, then the compiler will be saying, oh, you want to load into the accumulator a value, not something that's at a place, but a value. And the value in this case would be 0100. It's worth mentioning, I have no idea what that would do, because the accumulator is 8 bits, and the value you're trying to load is 16 bits, so I make no promises as to the behavior. It's a really dumb idea. But in the case of the HX register, that's a 16-bit register, and loading into it a 16-bit value makes a lot of sense. Then we want to go ahead and get the value of X into the accumulator with this TAX instruction. That's simple enough. It just transfers it over, overwriting whatever's in the accumulator. Then we're going to add I. Now this, because I didn't put an immediate value here, again, it's adding the value of I, which is to say that this I gets translated into hex 0x0100. That's an extended address. This is going to look, when it's in machine code, it's going to have some opcode, and then it's going to have 01 and then 00. It's going to be an extended addressing mode addition command that tells it go out to the address 0x0100 and then just add whatever's there into the accumulator. So that's what we want to do. We want to add whatever I holds to get to this ability to go to Zi. Then we're going to transfer that accumulator into X. Now it's worth noting that if X overflowed, though it's not a real problem in the address space, but it's a kind of a real problem in terms of getting to the address that we intended. So we'll get to this later. This is not actually a use case that you would do. This is a way to show you how addressing mode works. It turns out the other addressing modes exist identically to avoid having to do this whole section. All right, it's a common task to have to get to the ith element of an array, but if you don't understand how the HX registers work, good luck trying to understand the more advanced indexing modes. So we're going to transfer this into the accumulator. It's not going to overflow because we've just got 20 there and we're adding some value between 0 and 5. Hopefully we've done some boundary checking. But then we're going to finally just load in whatever is pointed to by the HX pair. That's what this says here. It says go look into the HX register. That HX register now holds 0, 1, 2, 3. If current value of I is 3, then it goes out and grabs the third element. So that completes what we did last time.